Hello and welcome to our introductory lecture on print technology. I'm Chad Westover and this is for GIT 537, Current Issues in Cross-Media Production. This lecture is going to be made up of two parts. The first is going to talk about the basics of print technology, which are as follows: screen press, letterpress or flexo, offset, gravure, digital printing, which encompasses many things including inkjet. So this is going to go fairly quickly. This is meant to be just an overview or a refresher on some of these technologies. But we'll talk a little bit more in depth about each of those as we go. Screen printing is a technique that's been around for quite a while. As the name suggests, this process involves pressing ink through a fine mesh or a screen to reproduce an image or design. Screen printing isn't typically a very fast process and is suited to smaller runs, and it works well also on non-standard items like t-shirts or skateboards and things like that. Letterpress and flexography are both rather similar techniques. Letterpress is a much older technique of the two. Both of them involve the application of ink to a plate with raised surfaces or a relief image. Those raised inked surfaces are then put into contact with your substrate, paper, plastic, whatever it may be, and the ink is directly transferred onto it using a cylindrical roller. That's flexo. In letterpress, a sheet of metal or wood is basically aligned with a bunch of tiny little metal characters or letters, and those are then, as you can imagine, pressed onto the paper, kind of like using a stamp. It's a high quality technique, but rather slow and expensive, and not very many people are using it for current production in letterpress. Flexography is used enormously in the packaging production. However, letterpress is, like I said, kind of slow. It's making a comeback though as a niche kind of high quality, short run production technique. Lithography, in contrast, uses a printing surface that is treated to repel the ink, except for in the image areas. So as opposed to the previous techniques that use a raised surface, kind of like a stamp, lithography uses a flat sheet, a metal sheet called a plate, which is imaged in a variety of different ways, but basically the effect is like oil and water. The ink sticks to certain areas and doesn't stick to other areas. That is then transferred onto a sheet of paper or substrate. Offset lithography, as the name implies, offsets the ink cylinder, the plate cylinder, and uses an intermediary cylinder called a blanket cylinder, which then receives the ink from the plate and transfers that ink onto the paper. Gravure uses heavy, large, expensive metal cylinders to press an image directly onto a substrate. The cylinders are engraved and the ink is held in the indentations of the engraving and cleaned off the rest of the cylinder with a blade, as you can see in the diagram to the left. Under very high pressure, that cylinder imprints the paper, and that's how the ink is transferred. Image cylinders are pretty expensive. They're difficult to work with. They produce excellent results, and they're very durable and fast. The quality is very high. The use for this is very high production runs, very long runs. As you can see in the photograph at the bottom right, paper is fed through on large rolls, so they're high volume. It's not just paper, it's metallic films and all sorts of things for packaging and whatnot. If you're curious, this is how money is printed using the gravure technique. It's not rotogravure, but it is a gravure technique with engraved plates. Digital printing is a relatively new process. There are a variety of technologies involved, but the basics are that every single sheet of paper is imaged digitally. There's no plate to change or cylinder to engrave, no ink being rolled out onto a cylinder and then stamped onto something. This allows for very short runs to be actually quite practical, because every single sheet can be unique and can be different. Variable data printing takes advantage of this, where a database of information can be merged with a print project so that every single sheet has a different bit of information on it. For example, a direct mail piece that you might receive in the mail, junk mail that you would throw away, but it's got individual name, it's got unique pictures, it's got data on it that applies to every single person based on a database that the marketer has available to them. So digital printing uses toner or specialized inks that are transferred electrostatically or otherwise. There's a video below in the link, that YouTube link, you can watch to learn more about that. Inkjet printing is probably the most familiar of the printing technologies to most people who haven't had a lot of experience with the printing industry. Inkjet is what you get in your desktop color printer, oftentimes, if it's not laser. But anyways, inkjet works on the basic principle of a spray paint can. You're launching droplets of ink at the substrate at high speed. these droplets of ink are extremely small. As you can see the diagram on the right, you read about what a picoliter is, but it's done with extreme precision. So it's not the similarity with the spray paint can ends right about there. The droplets form precisely placed dots of color, bigger than the individual droplets of ink, but those dots, when composed all together with the different colors, give you a full color image. Inkjet doesn't come into contact with the paper. It's done over a distance, so the print heads never touch the actual substrate. This allows for printing on a variety of materials as well. Different surfaces, curved surfaces. There are all sorts of print technologies emerging that are quite interesting with inkjet printing processes. There are many new technologies emerging that are going to reshape the print industry and the cross-media industry that we're involved in. There are expensive and respected channels of communication that this will apply to, and we're going to discuss a few of those going forward here. For example, nanographic printing or nanography. This is very interesting and exciting. There's a YouTube video there. Make sure that you click on the link to watch and learn more about it. Web to print, large format inkjet or grand format printing, 3D printing. Some of you may be somewhat familiar with that too, but we're going to talk about it a little bit different here. Interactivity using QR codes and especially augmented reality is going to be a big thing going forward. First up, web to print is a remote publishing solution for traditional printers. So instead of having a design shop come to your facility and provide you with the files for a document, instead you have a web portal where customers or clients can upload their documents and have them printed. The key to this is automation. So web to print involves a high degree of automation, and this is very technology based. There are a lot of things that are involved in this that we're not going to get into in this lecture. In some of the other classes, you may get more into that, like digital workflow, for example, GIT 450. But keep an eye on web to print. Our own print facility here in-house, the the Print and Imaging Lab, uses a web to print portal as well. Dye sublimation, or dye sub, or the long version, dye diffusion thermal transfer printers, basically work under the concept of vaporizing or converting an ink into a plasma that's then transferred over distance onto a substrate. This is used for everything from t-shirts to coffee mugs and mouse pads and a lot of the things that you may think of as GIFs, photographic GIFs or printed GIFs, where you have a sheet of metal that is printed on, for example, is another option for that. These are available in a variety of ways. The dye transfer process actually embeds the dye in the material, and it's a very durable printing process. Nanography is a quite interesting upcoming and emerging printing technology. There's a video link that will be available here in this lecture that I encourage you to watch on the next slide that gives a lot more information about it, but it enables very high-speed printing, very high quality, extreme resolution, great color, ability to print on all sorts of paper, coated, uncoated, whatever, packaging, film, labels, plastics, whatever you want to print on. It has a lot of options. It's also better for the environment, or has the potential to be anyhow, very low cost as well, very little waste of ink. Basically, the concept is you have ultra small particles of ink. The colorant that you use is measured in nanometers, which is billionths of a meter. These pigments bond very well, and they transfer with very little waste and can be, this is a very, very effective printing technology. So make sure and watch the video. Click on the image to the right here, and that will launch a YouTube video that discusses the technology and shows some demonstrations that will hopefully make more sense. 3D printing, you're probably somewhat familiar with. It's not a very new technology. It's been around for a little while. Traditional 3D printing, or what most people think of when they think of 3D printing, is done using material extrusion. Basically, think of a hot glue gun. You're squirting out some melted plastic and stacking that on top of each other to build a 3D structure. Or the other option is laser sintering, where a high-power laser melts or welds or fuses plastic or metal powder into a unified object that becomes solid. Both of those have some limitations as far as speed. because they only add material at one location at a time. Similar to when you're drawing with a pen versus if you're printing with a printer, you can print out a whole row or a whole page at a time. So watch the video here, click on the link that says HP Jet Fusion 3D printing video, and that's going to launch a video that demonstrates what we're talking about here with 3D printing solutions from HP, for example. Next up, we'll talk about emerging print technology. This isn't so much the printing technology itself, but it's other technology that's being embedded in printing and used in conjunction with it. QR codes have been around for a while. I'm sure that you've all seen QR codes before. Augmented reality is a way to take advantage of those QR codes by embedding certain information. As you can see in the image on the right, this is a children's publication, printed example, and the little lightning bolt icon is essentially a QR code that's going to launch augmented reality content through an app. You can try this out yourself. There's an app called Zappar, Z-A-P-P-A-R. The links for iOS and Android are below, and that's what the icon looks like, so you know what you're getting. But if you point your phone while you're in that app, if you point your phone at the screen of that Angry Birds cover, it's going to launch the augmented reality portion, so you can get a demonstration and see what augmented reality is all about. There are lots of opportunities for growth in augmented reality and lots of applications for it as well in commercial, advertising, marketing, medical research, all sorts of opportunities for this to convey additional information that can be updated. So if you print a document as simple as something like a business card and your information changes, you update the digital version of that on the back end. And so whoever has your card, at whatever point they got it, they scan that code and they get the most up-to-date current information. Another exciting emerging print technology is the field of printed electronics. I'm oversimplifying a bit here, but imagine laying down a line of conductive material. With enough of these lines and the ability to control the complexity of the design, sophistication, and everything, it's possible to efficiently produce electronics using faster, cheaper printing technology processes than the current circuit board manufacturing processes. We won't get into any more about the detail of the technology here and how it's done, but keep in mind that the potential for this emerging technology is tremendous. Things from printed LED panels and light bulbs to displays and interfaces. The potential is really kind of amazing, and the technology demonstrations that I've seen are quite impressive. In conclusion, we've covered many of the traditional printing technologies as well as some of the emerging technologies that are coming forward. Hopefully it sparked your interest a little bit to do some research and learn about these technologies and techniques and processes. Keep in mind that the print industry itself is enormous. It is an over $900 billion industry worldwide. It's a global industry that has opportunities in a huge variety of fields, from engineering to design to manufacturing and research and so on. It also ties into a multitude of other industries, everything from marketing communications, which is simple and straightforward, to everything else that you may not consider. Just about every other industry out there utilizes print technology or the print industry to some degree. So keep that in mind as you do your research and enjoy learning about print technology and the print industry.